All right, good afternoon, chemistry class. Today, in this episode of this podcast, we're going to be looking at naming and writing what we call molecular compounds. Now, if you're in a composition notebook from class, just continue wherever you left off last time. That should be around page number 27 and 28. And you might want to put a title up there, Naming Molecular Compounds. Now, we need to understand that when we name molecular compounds, we've got to realize that this only works for molecular compounds. Molecular compounds are compounds that are covalently bonded together. So, like I put there, covalent / molecular compounds. Now, remember, when you have a molecular compound, that means you have two nonmetals, nonmetal to nonmetal. Again, where are the nonmetals located? They're located on the right-hand side of the periodic table, to the right-hand side of that stair-step jagged line that we take a look at in class. And so when you have two nonmetals bonded together, you have a molecular compound. And there's a particular system that we use in naming molecular compounds. So just in the way of reviewing the different naming and writing systems that we have, first of all, we have ionic compounds. That's what we've been dealing with. And ionic compounds, that's where you write the cation, which is the positive element. You write its name. Then you write the anion. If it's a regular anion, the name or the ending is changed to IDE. And then also if it is a transition metal, then we use the Roman numeral. So that's kind of like the Roman numeral system. For our covalent or molecular compounds, we're going to use Greek prefixes, and that's what we're going to talk about in just a few moments. And then there's another system that we haven't dealt with yet, and that's a system of naming acids. And the way you identify acids is they are usually going to begin with the element hydrogen, followed by either a nonmetal or a polyion. So we'll talk more about that in a little bit as well on a different podcast. Again, make sure, this is very important, make sure you're using the correct naming system for the type of compound. The Greek prefixes only work for molecular compounds. When you're using ionic compounds where you have a metal bonded to a nonmetal, make sure you're using the correct system for ionic compounds as well. All right, you might want to take your notebook and jot these down someplace in your notebook. These are the Greek prefixes that you need to know. So jot these down in your notebook. You might want to pause at this point. Go ahead and write these down. Okay, so after you've written these down, if it's a 1, we use the prefix mono. 2 is di, 3 is tri, 4 is tetra, 5 penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Some of these you probably are familiar with, like a pentagon or a hexagon, octagon, or a decade, meaning 10. So, but the other ones you need to make sure that you learn these and that you get these down. And I will talk about how we're going to use them. All right. So now let's switch over and let's take a look at a few examples of how we write covalent compounds. So again, these are nonmetals to nonmetals. So our first example here is, let's do P2O5, all right? P2O5. So phosphorus is a nonmetal and oxygen is a nonmetal. So we have the prefix 2 here. So we have the subscript 2. So we're going to use the prefix di, and then we're going to simply put the element name. So it's diphosphorus, okay? Diphosphorus. And then we have 5 oxygens. So the prefix that we use for that is penta. So we're going to write pent oxide. Now we kind of leave off the A here because the pentaoxide doesn't really work well in the English language, so it's just pentoxide. So the name of this would be diphosphorus pentoxide. Notice here that the ending is changed to IDE. So very similar to what it was in ionic compounds. The second element, the ending is changed to IDE. So let's do another one. Let's do N4O10. N4O10. So here we have nitrogen, but what is the subscript? The subscript is 4, so we use the prefix tetra. So tetra nitrogen, and then we have oxide again, And what is the subscript? The subscript is a 10. So therefore, what's the prefix for 10? It's deca. So we say dec oxide. Again, we leave the A off of the prefix. So tetra, nitrogen, dec oxide. All right, let's do F2O. All right, so you're kind of getting the hang of this, hopefully. Here you have 2-fluorine, so the prefix for 2 is di. So we write difluorine. And then we have oxygen. And remember, if there's no subscript, it's understood to be a what? A 1. So the prefix of 1 is mon, and then we write oxide, monoxide. So difluorine monoxide. All right, so that's pretty easy. Now let's go the other way. It's pretty easy to go from the name back to the formula as well. So we did formula to name. Now we're going to go from name back to formula here, all right? So let's take a look at a few of these. Let's take a look at carbon. And this is one you're probably familiar with, monoxide, carbon monoxide, all right? And so we have the prefix carbon. So that's the symbol C, all right? And then we have oxygen, so that's O. And now what are going to be the prefixes? Well, carbon doesn't have anything on it. If it's the first element, we don't use the prefix mono. So since there's no prefix on this, we know there's just one carbon. So we simply leave it as is. Remember, the one's understood. And then we have monoxide, so that's one oxygen as well. All right. So let's do another one. Let's do tetra. Let's do tetraphosphorus. Okay. Dec oxide. All right. So the first thing, identify the element. The element is phosphorus, so that's the symbol P. Look it up on your periodic table if you don't remember the symbols. All right. And then we have tetra. So what does that mean? Well, that's 4. That means that you have 4 phosphorus. And then we have oxygen, and the prefix is deca, so that means you have 10. So tetra is 4, and deca is 10. So P4, O10. All right, let's do another one. Let's do nitrogen. And then let's do triiodide. Triiodide. All right. So nitrogen is N. Now, what's the prefix? Well, there's no prefix. So remember, mono is not used on the first element. So that means there's just one of those. And then iodide is I. And we have tri. So tri means 3. So Ni3. And so again, make sure you're using the correct system here. Don't get your systems mixed up. We only can use the prefixes if we're dealing with which types of compounds? Molecular compounds. How do you know if it's a molecular compound? You have a non-metal bonded to non-metal. Non-metal to bonded to non-metal. So that's the only time that you can use this system, all right? Here are a few more examples. Let's go back to formulas. Let's do P6O8. And let's name that one. So again, we have phosphorus, all right, and we have 6. So 6 is hexa. So we have hexa, phosphorus, and then we have oxygen, and we have 8 of those. So that is octaoxide. That's kind of a hard one to say, octaoxide, all right. And then let's do another one, OF2. All right, so we have oxygen. All right, now there's one oxygen, so it's mono, but we don't put mono in the first element. So we just leave it as oxygen. And then we have 2, so that's di, and then we have fluoride. And really, that's pretty much it. That's pretty much a system, a real simple system. All you have to do is memorize the prefixes, and it's pretty easy to go from the prefixes back to the formulas. And then from the formulas, you can also write the names by just adding the prefixes. So we'll talk more about this in class, and we'll do plenty of more examples and do some worksheets and a lot of practice. So I'll see you next time in class.